Hello, I'm Mrs. Ruma Dhanwate from Aryan College of Arts, Commerce and Science. In this video lecture, we shall see Introduction to Patterns. We shall see what is a design pattern, what makes a design pattern, that is gang of four patterns which is also called, how to describe design patterns, what are the pattern categories and relationships between the patterns, how do we organize the catalog, and patterns and software architecture. Design pattern. A design pattern is a general repeatable solution to a commonly occurring problem in software design. A design pattern isn't a finished design that can be transformed directly into a code. It is a description or template for how to solve a problem that can be used in many different situations. Design pattern describes a problem which occurs over and over again in our environment and then describes the core of the solution to that problem in such a way that you can use this solution many times without ever doing it again. What are the elements of a pattern? The pattern has four essential elements. First is the pattern name, second is the problem, solution is the third one, and the consequences. We shall see elements of pattern. First, the pattern name. The pattern name is a handle we can use to describe a design problem, its solutions and consequences in a word or two. Naming a pattern immediately increases our design vocabulary and allows us to design at a higher level of abstraction. Having a vocabulary for patterns lets us talk about them with our colleagues in our documentation and even to ourselves. It makes it easier to think about designs and to communicate them and their trade-offs to others. Next is the problem. The problem describes when to apply the pattern and explains the problem and its context. It might describe specific design problems such as how to represent algorithms as objects. In addition, it might describe class or object structures that are symptomatic of an inflexible design. Sometimes the problem will include a list of conditions that must be met before it makes sense to apply the pattern. The solution describes the elements that make up the design, their relationships, responsibilities, and collaborations. The solution does not describe a particular concrete design or implementation because a pattern is like a template that can be applied in many different situations. Instead, the pattern provides an abstract description of a design problem and how a general arrangement of elements solves it. The consequences are the results and trade-offs of applying the pattern. Though consequences are often unvoiced when we describe design decisions, they are critical for evaluating design alternatives and for understanding the costs and benefits of applying the pattern. The consequences for software often concern space and time trade-offs and may address language and implementation issues as well. Since reuse is often a factor in object-oriented design, the consequences of a pattern include its impact on a system's flexibility, extensibility, or portability. Listing these consequences explicitly helps you understand and evaluate them. A format of design patterns. There are 13 points. First is pattern name and classification. Then comes intent, also known as that is the other name for a design pattern. Motivation, applicability, structure, participants, collaborations, consequences, implementation, the sample code, known uses, and the related patterns. Now, In this slide, you will see what these 13 points mean. The first is pattern name and classification, and it means pattern's name conveys the essence of the pattern. The second is intent. What does the design pattern do? What is its rationale and intent? What particular design issue or problem does it address? Also known as, that is the third point, other well-known names for the pattern, if there are any. Motivation, a scenario that illustrates a design problem and how the class and object structures in the pattern solve the problem. Applicability, what are the situations in which the design pattern can be applied? What are the examples of poor design that the pattern can address? Then the structure, 6 point, a graphical representation of the classes in the pattern using a notation based on object modeling technique, that is OMT. Then participants, the classes and or objects participating in the design pattern and their responsibilities. 8 point is the collaboration, how the participant collaborate to carry out their responsibilities. Consequences, how does the pattern support its objective? What are the trade-offs and the results of using the pattern? Implementation, what pitfalls, hints, or techniques should you be aware of when implementing the pattern? Are these language-specific issues? Sample code, code fragments that illustrate how you might implement the pattern. Known uses, examples of the pattern found in the real systems. Related pattern, what design patterns are closely related to this one? What are the important differences? With which other patterns should this one be used? So these were the 13 points. So these were the 4 authors of the book, Design Patterns, Elements of Reusable Object-Oriented Software. And 20 years ago, this book was published. Now, these 4 authors are also called as the Gang of Four, and they have found out these patterns because they have been doing coding in C++, that object-oriented language, and around 23 patterns they have recognized. Now, how to classify the patterns? There are 2 ways. The first is the purpose, and second one is according to the scope. Now, this Gang of Four design patterns are broken into 3 categories. The first one is creational pattern, second is structural pattern, and third is behavioral pattern. So creational patterns are used for the creation of objects. Structural patterns are used to provide relationship between objects, and the behavioral patterns help us to define how the objects will react. Now the second way to classify the pattern is according to the scope. Now this criteria specifies whether the pattern applies primarily to classes or objects. So class patterns deal with relationships between classes and their subclasses, and these relationships are established through inheritance. So they are static, fixed at compile time. And the second is object patterns deal with object relationships which can be changed at runtime and are more dynamic. So the creational class patterns differ some part of object creation to subclasses, while creational object patterns differ it to another object. The structural class pattern use inheritance to compose classes, while structural object patterns describe ways to assemble objects. The behavioral class pattern use inheritance to describe algorithms and flow of control, whereas the behavioral object patterns describe how a group of objects cooperate to perform a task that no single object can carry out alone. Now the Gang of Four, the authors, they have used creational, structural and behavior patterns. Now in these patterns also there are class patterns and object patterns according to the second way of classification, that is according to the scope. So Combining these two, you have creational class patterns, creational object patterns, the structural class patterns, structural object patterns, behavioral class patterns, and behavioral object patterns. So in this slide, we see how the catalog is organized. Now, we have seen the two ways to classify the patterns according to the gang of four authors, and that is according to the purpose, and the second one was according to the scope. So if you see in this diagram, you will see the purpose on the top, and on the left hand side the scope, that is the class and object, and on the top purpose, that is creational, structural, and behavioral. So if you see here the creational patterns, you have 5 patterns: factory, abstract, factory method, abstract factory method, then you have builder, prototype, and singleton. Now, structural, you have adapter pattern, bridge, composite, decorator, facade, flyweight, and proxy. And then the behavioral, you have interpreter, template method, chain of responsibility, command, iterator, mediator, memento, observer, state, strategy, and visitor. Now, if you see here on the left hand side scope, that is according to the class and object. So the factory method, adapter, and interpreter and template method, they are all the uh, class type of methods, and all the others are object type of methods. Now this is the catalog of the design patterns. The first is the abstract factory, and what it does, provides an interface for creating families of related or dependent objects without specifying their concrete classes. Next is the adapter, convert the interface of a class into another interface clients expect. Adapter lets classes work together that could not otherwise because of incompatible interfaces. The third is a bridge, decouple an abstraction from its implementation so that the two can vary independently. Build a pattern, separate the construction of the complex object from its representation so that the same construction process can create different representations. Chain of responsibility, avoid coupling the sender of the request to its receiver by giving more than one object a chance to handle the request. Chain the receiving objects and pass the request along the chain until the object handles it. Sixth is a command. Encapsulate a request as an object, thereby letting you parameterize clients with different requests, queue or log requests, and support undoable operations. Composite pattern. Compose objects into tree structures to represent part-whole hierarchies. Composite lets client treat individual objects and compositions of objects uniformly. Decorator, attach additional responsibilities to an object dynamically. Decorators provide a flexible alternative to subclassing for extending functionality. Ninth one is a facade. Provide a unified interface to a set of interfaces in a subsystem. Facade defines a higher level interface that makes the subsystem easier to use. Next is the factory method. It defines an interface for creating an object but lets subclasses decide which class to instantiate. Factory method lets a class defer instantiation to subclasses. Flyweight use sharing to support large numbers of fine-grained objects efficiently. Interpreter, given a language, define a representation for its grammar along with an interpreter that uses the representation to interpret sentences in the language. Iterator, provide a way to access the elements of an aggregate object sequentially without exposing its underlying representation. 14th is a mediator. Define an object that encapsulates how a set of objects interact. Mediator promotes loose coupling by keeping objects from referring to each other explicitly and lets you vary their interaction independently. Memento. Without violating encapsulation, capture and externalize an object's internal state so that the object can be restored to this state later. Observer, define one-to-many dependencies between objects so that when one object changes state, all its dependents are notified and updated automatically. Prototype, specify the kinds of objects to create using a prototypical instance and create new objects by copying this prototype. Proxy, provide a surrogate or a placeholder for another object to control access to it. 19th is a singleton. Ensure a class only has one instance and provide a global point of access to it. State. Allow an object to alter its behavior when its internal state changes. The object will appear to change its class. Strategy. Define a family of algorithms, encapsulate each one, and make them interchangeable. Strategy lets the algorithm vary independently from clients that use it. Template method. Define the skeleton of an algorithm in an operation, deferring some steps to subclasses. Template method lets subclasses redefine certain steps of an algorithm without changing the algorithm's structure. And the last one is visitor. Represent an operation to be performed on the elements of an object structure. Visitor lets you define a new operation without changing the classes of the elements on which it operates. So these were the 23 design patterns according to GOF, that is Gang of Four authors. Now this is a reference. Thank you.